Okay, I think we're back. Okay, good. So it's important. Combining like terms, do not change the variables. Don't change the variables, don't change the exponents. Combining, again, that's adding or subtracting. We'll get to multiplication reals. We might even do some of that today, Carol. Okay? You with us, Carol?
Yep.
Right. So this one is fairly long. Let's just try it. We'll do one of these and then maybe we'll ask somebody to share their screen. So this question is we want to simplify and we're going to write it just like this. Please copy this as carefully as you can. Three terms. What do we call three terms, Bakelu?
Seven.
What's the, this is three terms. What do we call this?
Is trinomial.
Very good. Yes, good. So it's a trinomial subtracted by another trinomial. So I'm going to do the first line. We do the first line together, and then the rest is on you. Ready? Let me wait till you all have that copy down. Then we will proceed. Ready?
Yes.
Yes.
Okay, this first trinomial, in front of it, you don't see anything, which means there's a plus sign in front. If you have a plus sign in front of this parentheses, we can take them out of the parentheses. However, this second trinomial has a negative sign in the front. That means this negative sign we have to distribute through every term inside the parenthesis. So this negative with this positive makes this negative 3x squared. What would I write next? Negative 6x. Don't forget the x.
And then would that be positive 4?
Positive 4, yes.
Positive 4, yeah.
So everything's out of the parenthesis. We're going to combine like terms. I would like to see this answer that will go in the box on your whiteboard. Let's see what we got on the whiteboard. Not yet, still waiting. Okay, I'm seeing, okay, Freeman, thank you. Waiting for some others. Love to see a few others. Anybody else? Thank you, Brian. Got Carol's almost finished. I see Taylor. Let's see what Latrice has. Looking at Latrice.
Now I got a little confused. Like I don't know.
Why did you just take the, why did you drop off the exponent? You can't just drop the exponents off.
I dropped it off because I was like, okay, X symbolizes 1. So I was like,
Oh,
X
wait,
times
the
X.
coefficient. No, this we're talking about the coefficient might be 1, but you just can't, you can't just drop off the
Oh Lord. Yeah.
okay, so the first thing we should write here, descending order. The highest exponent has the power of 2. So these coefficients combine to 2. The exponents do not change, Latrice. If it's x squared is x squared. The exponents and the exponents do not change. The other like terms are, let's see. Yeah, Freeman's got it. The other like terms, minus 2x, minus 6x, minus 8x. The variable does not change. And 11. Okay.
Okay, good. So I was right. Okay.
Can we share somebody's screen? Maybe Freeman, is yours handy?
Let me make sure I log. Go to Canvas. You want me to go to Canvas, Professor?
Yes.
Okay. I'm going now. I wasn't logged in.
Okay. So we'll do a few on the homework, and then we're going to probably go to some multiplying. Carol wants to do some multiplying, I think. So we should oblige. We should probably oblige. So we'll do exactly that. Oh, no. You have it up yet? Ready? Let's see.
Yes. Can you see?
Okay, beautiful. Yes. Perfecto. So let's scroll down. Let's see. Yes,
3
right
lesson
there.
4.
That's correct.
Want to do this one?
Yeah, what's the degree? Let's go with that first.
Hmm.
So they're talking about for the entire polynomial. Yes, go ahead.
Okay. It is. Let's see. 6.
No, the degree is, somebody tell me what the degree is?
Oh, 2. Is it 2?
In general, what's the degree in general? Degree is the exponent.
Exponent,
So
yes.
when they ask for the degree of the polynomial, they want the highest exponent that you see in that polynomial expression.
Oh, so it'll be 3.
It'll be 3.
Yes.
Now, they asked for the leading coefficient. Now, they did not ask you to write this in descending order. They didn't say anything about descending order. So what we're going to use, since they didn't say descending order, we're going to use the way this is written out.
Okay.
So
So the leading coefficient will be 7.
well, you can't forget,
Negative 7.
yeah, you have to put that negative there. So
Okay.
they didn't say anything about descending order, so we're just going to use that. So let's try the negative side.
You said it's wrong.
All right, so
Do I
that
have to
means,
put? Oh,
so that
Yeah.
means that they
Yeah.
will want us to write that in descending order. So if we were to write that in
It'll be-
descending order, descending order of that polynomial would be negative y to the third, negative 7y squared minus 12y plus 20. I'm writing those down in the, from the highest exponent down to the constant. So do you see my white paper here? Yeah. So this is
yes.
that polynomial written in descending order. So written in
The leading
descending,
coefficient will be negative 1.
negative 1.
No. Yes.
So let's try that. Let's go to number 2. Let's go to number 3.
Okay.
Should we try that one?
You want to do this one?
Yeah, okay, let's write this down on our paper. And then we will do this together. Because we have three trinomials here. So we didn't do one like that. That's worth doing. Make sure you write this down with the details. Make sure you have all the details. Okay. Make sure that we copy this down correctly. It's important to pay attention to the details. All right. So when you have this copy, I'm going to stop sharing screen for a minute, then we're going to work this one out together.
Okay.
So do most of you have this copy?
Yes.
Yeah.
Taylor, no. Taylor says no, correct? I think Taylor says no. All right, we get Taylor a few minutes. Let me know when you're ready, Taylor. Now, while we're waiting for Taylor, if those who want to work it out, please try to do so. Put your answer on the whiteboard and we'll check that in a few minutes. So it's the same procedure. We are going to take things out of the parentheses. If you have a negative sign in front of parentheses, you have to distribute the negative sign as you take them out of the parentheses. So can we stop sharing? You had that, Taylor? Can we stop sharing the screen?
Okay.
Okay, so now do some of you want to take a few minutes and try yours yourself, or should we just do this all together? What's your preference?
Can we try it? You just give us a couple of minutes to try it ourselves.
Yes, absolutely.
Yeah, let me try to work this out.
Yes, yes, yes. I think I like Stephanie's little picture there. That's different.
Thanks, Professor. That's my niece.
Oh, okay. Like the picture. Okay, so whenever you are ready, we can put the answer on the whiteboard and we'll see how we do. So when I ask you for leading coefficients for these problems, make sure you write things in descending order. That will give you the highest power first. The highest power will be the degree of the entire polynomial, and then the coefficient of that first term will be the leading coefficient. So I'll be interested to see what the first term is that we write out.
Professor, I couldn't write mine, but I got an answer.
Okay, let's hear it.
Put your paper back.
Can you see it?
No, put it up some more
How's that?
and over to the left.
Over to the left.
The
Other left?
left, yes.
Hey, that's a great start, Carol.
Right a little bit.
To this?
Yes.
Okay.
I got 21 U to the second,
Nice, good, yes.
and it was wait a minute. Negative 12 and plus 6. And it's negative 6U.
Okay.
And it's negative 5. Oh, wait a minute, I missed the 3. Positive 3. Negative 8.
Negative 8. Okay. Let's see. Can anybody confirm that?
Yeah.
I got something slightly different.
That should be right.
That's right, Professor. I think it's right.
All right. I got a lot of confirmation there.
That's right.
So we're going to take this first trinomial right out of the parentheses because there is not a negative sign in the front, so it can come right out. The same with the second trinomial. 9u squared minus 5u minus 3. Now with this negative sign, we distribute it with all the signs inside that parenthesis, makes that positive 7u squared minus 7u, and that is a plus 3. That's pretty long. Many terms there. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. The like terms, u squared, u squared, u squared. 5, 9, 14, and 7 is 21 indeed. So that 21 was good, 21u squared. Now we look at the u's, positive 6, u minus 5, 6 minus 5 makes that 1. 1 minus 7 is minus 6u. So that's also good, Stephanie. And then the number. Negative 8 minus 3 is negative 11. Negative 11 plus 3 is negative 8. So that's a bullseye, Stephanie.
Thank you. Good job, huh?
And a few others. There were others. Let me get that whiteboard back.
I was waiting.
As the others were Carol, Bakelu, I thought I heard Brian. Oh, Brian, no, wait a minute. Brian didn't put anything up there for that one.
I put it on my paper, not on the board.
Oh, but come on, man, put it on the board. Okay, let's share your screen again, Freeman. And you know what answer to put in? Yeah, we hadn't done one with 3 trinomials, so that was nice. That was nice. Minus 6u, right? 8, yes.
Right? Where
Let's
you want me
look.
to go to now?
Yeah, let's just look at 4. Yes, let's look at 4. No, let's look at 5. We got that. Let's go to 6. 7. Let's go to 8. Just put those in descending order, and we got that. And go to 9. Okay, let's close it out. Let's just close it out. Now,
Okay.
I will say keep. I tell you what, we're going to stop sharing the screen. In a minute, we're going to go back to your screen again, but we're going to go to the next part that Carol wants to see, which is multiplying. So we're going to go to some. Now we're going to multiply and divide. Multiply. Okay, all righty. So there's a couple of rules with this. There's a couple of rules with this. And really, it's the power. We're really using the product rule for exponents. Do you remember what the product rule for exponents was? It was, if you're not sure, it'd be like if we had x to the second times x to the third. What's this answer, please? X to
Would
the
it be
second.
x to the 6?
2 to the power of 6. Oh, x to the power of 6, sorry.
Well, all right, hold on a second. Let's try this. We have 2 examples here. What's that, Taylor?
You add the exponents.
Ah, okay. So we have two examples here. So, and a first example, what should the answer be, Taylor?
X to the fifth power. X to the
Yes,
fifth
it'd
power.
be 5. Yes. And example 2, Taylor?
X to the sixth power.
Yes. Now, what's the difference between these two? What's the difference?
The exponent is outside of the parentheses.
So when you have exponent outside of parentheses, this is the power rule. Whereas up here, the product rule, you just add the exponents. Do we remember that a little bit?
Mm-hmm.
So this is important to remember this. Multiplying, we adding those. Got it? But when we have a power outside of the parentheses, we have to do what Taylor said. That is a big difference. Is that clear though? Everybody?
Yes.
Carol, you listening?
Uh-huh. I
What
see.
about Latrice?
I'm here. I see the difference.
Okay, Latrice, we'll find out. Let's say right now. So the direction is going to be simplified. I'm gonna write a problem out, and I'd like you to put the answer on the whiteboard. Let's start off with this. Two XY times I look forward to seeing your answer on the whiteboard. Let me minimize this, and okay, here we go. Okay, no answers yet. That's fine. We'll wait. Oh, we got Latrice. That's got to be an old one. Ah, there's a new one. Let's see, Latrice. That is. Thanks for trying it, Latrice. Got a little slightly off. Thanks for that's a great effort.
Can I try, Professor?
Yeah. Are you putting your answer on the?
Yeah.
Oh, there we go, Carol. Wait a minute. That's something. I don't see your answer, Carol.
I'm about to write it now. How mine's look, Professor?
Freeman, sorry. That's close. That is close. That's very close, Freeman. That's very close, McKellar. Actually, it's not as close as Freeman. Waiting for Steph. What happened to Stephanie? Stephanie's gone.
I was looking so far, Professor.
Professor, I switched from my phone because it died to the computer. And for some odd reason, I can't get to the whiteboard. But I do have an answer. I don't know if it's right.
Let's hear it.
I got 10xy to the third b.
Okay, that is close. Hey, Brian has the bullseye answer.
Did you see mine, Professor?
That's Carol.
Yeah.
Oh, hey, Carol, you have the bullseye answer also.
Okay.
You and Brian are bullseyes. Okay, so let's explain right now. Now the great news is those two numbers, pretty much everybody had the 10 here. Here is the but. Here's the but. But what is the exponent of this x?
One.
1. Thank you. What's the exponent of this y?
One.
1.
Thank you. What's the exponent of this x?
1.
1.
And the exponent of this y is 1. So the 2 and the 5 do give you 10. But what should be the exponent next to the x?
Square. 2.
Thank you very much.
Two.
I didn't see too many
Oh,
twos here.
okay. Okay.
You're supposed to add the exponents.
I forgot.
I didn't see too many twos there. Now the good news is I did see several threes here. The 3 should be there. Let me see that 3. The 3 should be there, and then just a z at the end.
Okay.
So you have to be mindful of the details. So you have to add the powers of the like variables. Is there a question there?
No. No.
All right, let's try a couple more. Yes, let's try this. That is this is a z. So put your answers on the whiteboard in the box for those able to access the whiteboard. And for those who cannot, I guess I can just hit, you can just tell me your answer.
Professor, I got an answer. I don't know if it's right again.
Okay, let's hear it.
25x y to the 6 2z.
Did you say 2z?
Yes.
We don't like that 2z. We don't need the 2. You gotta do something with that 2.
Oh, okay. 50.
Okay.
50 x y to the 6 z. Right or wrong?
Okay, can we get a confirmation, somebody?
No. Hold on.
That's right.
Okay.
That's right.
Brian has confirmed,
That's right, Professor.
and so has
yeah.
Taylor.
Yep.
Awesome. So we multiplying this -5 with this -5. That is 25. Times this 2 will give us the 50. I agree. This x is to the first power. There's no other x's, so let's put the x here. The y, 4 is here, 2 is here, so we're gonna make that a 6. And that's the only z, yes. Okay, that's it. That's good. Questions on this? Freeman,
Oh,
Taylor, is that okay?
Mm-hmm.
All right. What about Latrice Allen?
Yeah, I mean, I'm sure it's right, but I was just trying to figure out. So basically, you added the number. Well, you did the numbers and stuff first, and then you just added the variables next to it.
I added the exponents of the like variables.
Right. Okay. And then you just added the variables x and y. Did you do anything with x and y plus the
I didn't do
y
anything. I
from
didn't
the
do
negative
anything with
y?
the X or the Z because there were no
Okay.
other X's or Z's.
Oh, okay. All right.
Okay. Moving right along. Very nice. I want to do two binomials. So there's a binomial multiplied by binomial. And we're going to multiply. So we're going to do this first one together. And I'll let you do the second one using the whiteboard. So two terms here, binomial, two terms here, binomial. Binomial times binomial. Many books explain multiplying binomials by using, they call this thing called FOIL. That's how they explain multiplying two binomials. So FOIL means the following. We multiply the first terms. The first term in this binomial, the first term in that binomial. So the 6 and the 4 is 24. And the x with the x, we add the exponents. So that's 24x squared.
Professor, can you move your paper up a little bit? Thank you.
So we multiply those first terms. 6 and the 4, and the x and the x. So this is the first. F is for the first. Then we multiply the outer. So that's the 6x with the 3. The 6x with the 3. What does that multiply to? 6x times 3 is
18.
18.
18.
18 what?
18.
18.
Thank you. And they call this the outer. This outer. Then we do the -2 and the 4x. Multiplying these two gives us what?
8.
8x.
Okay, -8x.
-8x.
So they call this the inner. I for inner. That's the inner terms.
Oh, don't elevate it too high.
And then the last. The last is the -2 with the 3. So that's -6. So when you multiply two binomials, you should have 4 terms in that next line. Question about these terms right here, anybody?
Yeah.
That's fine? So the last line is we're going to just multiply, sorry, we're going to combine whatever like terms that we see.
Mhm.
So there's nothing There's no other x squared term, so we write that first. These are like terms. The terms in the middle should always be like terms when we do the FOIL. Usually, let's say usually, maybe 99 or maybe 100% of the time, these are going to be your like terms. So this gives us, what does this equal?
10.
10x, and then the number on the end. So this would be
Can
our,
you move your paper up a little bit?
thank you, yes, sorry.
You gonna make the top.
So we're going to try one of these, another one of these on the whiteboard. Then we may share the screen of Freeman once more.
Okay.
But let's try this other example. Where is it? Oh, here we go. Here we go.
Professor, can you push your paper up? Okay.
So that's b minus 7, 3b minus 7. So I'm going to ask you to multiply these two binomials out like we did these two binomials and put your answer on the whiteboard, final answer on the whiteboard. So we're going to have a line here and then a final answer there. What goes here and what goes in the box.
Professor,
Yes.
got negative 25b plus 49.
Negative 25b plus 49. Any confirmation? Any confirmation? That's negative 25b plus 49. Listening for any confirmation. Move this up a little bit. Wait, let's see what is on some whiteboards. I don't see any whiteboards. No one put anything on a whiteboard yet.
Hold on, Professor.
Yep. Okay, thank you, Bakelu. Thanks. Oh, I thought Carol had something.
I did, but I erased it because I wasn't sure if it was right.
Oh, put it back, Carol.
Okay.
Sorry.
B.
You still working, Freeman?
Yes.
Let's see, Latrice. What's on Latrice? Oh, we gotta multiply that third term, Latrice. Supposed to multiply that third term, Latrice. Okay, I'm liking Carol. I'm at Carol and Pekelu. The middle term is different. You have two different middle terms. So we got to figure out who is accurate. Though Taylor, okay, Taylor, I see the first term, second term, waiting for Taylor's last term. I see the plus sign,
Mm.
and I see that. And Taylor, legging, okay. So Taylor and Carol have the same answer. So I'm gonna think those are correct. Nice job, nice job. Oh, even Freeman's coming with something. Should I wait for you, Freeman?
That's it, Professor. I tried.
Okay, so here we go. The first terms, we multiply b times 3b. Answer is?
3b star.
3b squared. 3b squared.
Okay, good, yes. Then we do the outer terms, b with times -7. Answer?
-7b.
Thank you. Now we do the inner terms, Latrice, the inner terms. That's a -7, that's a 3b. That multiplies to what?
21.
-21b.
-21b, correct. And the outer terms, the -7, -7,
49.
49.
That's 49. Okay.
So I was referring to this right here, Latrice.
I
That's
see where, yeah.
Yeah, I see that.
So 3b squared comes down. The -7b minus 21b, combining two numbers with the same sign, add. Keeping the sign, and then the 49 is at the end. There is your answer.
Okay.
Questions on that one, please?
We add them 721 with adding.
Yes.
Me too.
They're both negative, so add them, keep the sign.
Well, it was right. Okay.
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 Okay, Carol, not Carol, Freeman, let's see your screen.
Okay.
All right, have a good weekend, Miss Victoria.
Good night, Victoria.
Good night, Victoria.
Oh, hold on. Professor.
Thanks for all your help.
And thank you all for partaking of her availability.
Yes, Lord.
Hold on, Professor.
All
I
right.
haven't seen it.
Unless somebody else want to share this, does anybody have other screens as handy as Freeman?
Okay.
Some kind of way I got logged out, so. Oh, here we go.
Well,
Yeah. Okay. All
Hey.
right. I can go back.
okay,
Hold on, Professor.
all right.
Can you see it?
Sure can.
Where you want me to go?
Let's see where we at. Let's take a look. Scroll down. Let's go to
Keep
lesson
going.
5. Yep.
Okay.
Okay, let's go to number 2. Number 3. Okay, hey, let's try that one. Yep. Let's copy that one down and get this one a shot. This is we have multiple letters going on here. So after you copy this down, I ask you to try it on your sheet of paper. And then let's see what we get on the whiteboard. So does everybody have this copy down?
Yeah.
If so, I'm gonna
Yes.
stop sharing so I can see the whiteboard. All right, Freeman?
Okay.
I got
Yes.
it. Yep.
D 5 minus 5 D 3 and then negative 6 C 6 G. Okay. Now let's do the like terms first. So then
Is that
negative
Latrice? That is. Okay, that's good, Latrice. All right. Let's see, is Brian still with us? I don't think so. I hope Bakelu's still with us. Right, you still there, Bakelu?
Yes, yes, Professor.
Okay, okay, good.
Yes.
Professor, is this a Fourier method?
This is not, no, because
All right.
you need two binomials, so this is not the Fourier method.
Okay.
That second parentheses is one term. Stephanie's gone? I guess so.
No, Professor, I'm here. You know I couldn't get the whiteboard, but I'm here.
This is true. This is true. Right, right. Okay, you have an answer for this one, or you need some more time?
Oh, wait a minute.
Okay, I'm getting. Oh, Brian is still with us.
Oh, because of course tomorrow is a half a day for all.
Yeah.
Sending Taylor home, and I need somebody to fix that up. So, Lord's probably telling me, oh no. You sent Taylor home?
Let's see, Latrice Allen.
Look, Professor, I'm confused. I tried. I don't know.
What is that noise? Oh, that's Stephanie doing something. Man, I have to mute Stephanie.
Oh, I'm sorry.
On the lawn or something.
So that is all right. All right, Latrice, let's see who else. Let me minimize for a second, see the whiteboard, and he finished? No, I don't think Brian's finished. I'm assuming Brian's not finished. He's close. But Kelu is close. Let's see. Question mark from someone, got it? All righty.
Me.
All
I'm having trouble with this one, Professor.
right. So I can't really tell it. That's the old one.
That's the old one, Professor. I'm doing it now.
Is this right? It's kind of confusing though.
It's
Yeah.
kind of, let's see,
I'm
that's that a
lost.
4.
Yeah.
I'm gonna say that's right, Brian. I'm gonna give you
All
I
right.
want to say 100.
That's a 4.
I think I'm going to, that's a 4. I think I'm going to give you a 1. Hold on, wait a minute. I gotta look. Okay, I gotta make one thing a little larger. Let's see here. That's a 6. Oh, okay, yes, I'll go with that. And okay, yes, very good, Brian. Yep. And let's see, I see Bakelu.
I'm trying this one.
All right, so let me get this a little larger, and here we go. All right, so this second parenthesis, that's all one term.
All right, is it mine's up there now, Professor?
All right, hold on, Taylor. Let's go back for a minute.
You might can't see it. It's probably a delay.
That's minus 12. I think that is, oh, that's the same one. Okay, so I got you, Taylor. Let's see. So Freeman, this is one term.
Okay.
So this
I wasn't too sure what to do with the 5.
one term, we're gonna multiply with all of this. So let's do that one first. We're gonna have a negative 18, right?
Yes. That's as far as I got.
Then we have the C variable. Now, what is the exponent of the C? We're going to take these two exponents and add them.
And I'm so it'll be 8.
8. What we do with the variable, the exponent for the D? This is a 5. This is a
1.
1. So that's going to be a 6. So that's multiplying this one term by this first term here. The 3 and the minus 6 minus 18, add those exponents, 8, add those exponents, 6. Now, the same monomial multiplied by this first term, by the second term right here. So negative, negative. So this is going to be a plus here.
30.
30. Now this C is to this exponent, and there are no C's over here. So this stays to the 6. The D variable, this is 3 here. And there was how many here?
1.
So it makes this a 4.
No, hammers.
Yeah,
Come
say
on,
this.
Carol.
Say that again.
Oh, okay.
So with the second term, you see where the 30 came from. We have a C to the 6 here. There are no C's here. So it stays to the 6. This D is to the 3rd. And this is one more. And that's why it's a 4 here. So Freeman, we're going to ask you to share your screen, input the answers correctly. When you do so, we can leave. Good job, Taylor.
Huh?
we've had a long day, but you've hung in there very well. No, nice job, everybody.
Yes.
Okay, let's see. This should be good.
Yeah, boy.
All right, so it is 8:14. So we can stop at 8:14. Taylor, I think that seems reasonable.
Why you gotta call my name? What I did?
Nothing at all. That's fine. Great job, everyone. Nicely done. And have a great weekend. Unfortunately, I will not be available this weekend, but come Monday, I'm at your service whenever you would like to discuss whatever.
Okay. I have a good weekend.
Can I text you on Monday so we can set up a date to meet?
Yes. Please
Okay.
do. Yes.
Okay. Thank you.
Okay.
Okay.
Everybody enjoy your weekend.
You
You
too.
too.
Yeah, thank you.
All right, everybody. Very good. Bye-bye.